This is part 2 of the cast rule. Now I realize that in part 1 I didn't actually mention the cast rule by name, but we used the results of it, so that's why it was called cast rule part 1. So here we go. Cast rule part 2. Let's suppose we have an angle somewhere between 0 and 90 degrees. So that puts us somewhere along here. Now considering the trig ratios, the sine is opposite, or the y value, over the hypotenuse. The cosine is adjacent over hypotenuse, and the tan is opposite over adjacent. So if I draw my triangle in here, this is my y value, my x value, and my r value. And the sine of theta is y over r. The cosine of theta is x over r, and the tan of theta is y over x. If I'm between 0 and 90 degrees, x is positive because I'm at the right, y is positive because I'm above the line, and r we always call positive. It's just the distance to the origin. So when I'm in this quadrant, what is positive? Sine, cosine, and tan. So I can say all my primary trig ratios are positive when I'm in this quadrant. Let's now rotate from along the positive x-axis counterclockwise past 90 degrees. So now I'm between 90 degrees and 180 degrees. I'm going to call this angle theta 2. This is my y value, and over here is my new x value. So I'll call it x2 and y2. And here's my r value. When I'm over here, as you can see, the y value is going to be positive because I'm above the line. The sine of theta 2 is y over r. Y is positive and r is positive. So over here, the sine is positive. The cosine, the x value over the r value, is negative because this x value is clearly negative. We have gone to the left of the origin, and everywhere on the left of the origin the x value is negative. So the cosine is negative. The tan, which is the y value divided by the x value, is also negative because again we have a positive divided by a negative. So the only thing in this quadrant that's positive is sine. Here, all primary trig ratios, sine, cosine, and tan, are positive. Here, only sine is positive. Let's continue to rotate. So from here, if I rotate past 180 degrees over here, so I'm between 180 and 270 degrees. I'm going to call this angle theta 3. What's going to happen with theta 3? Here's y3, and here's x3, and here's r. The sine of theta 3 is y3 over r. This y is clearly negative, as I am below the line. A negative divided by a positive gives us a negative. So the sine of theta 3 is negative. The cosine of theta 3 is our x value divided by our r value. And cosine, in this case, is a negative divided by a positive, so the cosine is negative. Now consider the tan of this angle. Tan is y over x. In this case, y is negative, and x is also negative. What's a negative divided by a negative? Clearly, the tan of this angle must be positive. Remember, we get the tan of this angle by dividing this negative number, it's negative because we're below the line, by this negative number. It's negative because we are to the left of the origin. So down here, tan is positive. If we continue to rotate past 270 degrees all the way over here, so we're 0 towards 0 or 360 degrees. if we continue to rotate all the way here, I'm going to call this y4, and x is the same as x4. On this angle, theta 4, the sine is y4 over r. y4, as we are below the line, is clearly negative. Because it's negative, y divided by r is negative, so over here, an angle anywhere between 270 and 360 is going to have a negative sign. X is positive over here. Whenever we're to the right, x is positive. X over r is going to be positive, so when we're over here, our cosine is going to be positive. And furthermore, our tan is going to be negative. Remember, our tan is y over x. Y is negative, but x is positive, and a negative divided by a positive gives us a negative. So what I've written in here is the name of the primary trig ratio in each quadrant, which is positive. Here, cosine is positive. Here, all are positive. Here, sine is positive. And here, tan is positive. And if we begin here and spell this counterclockwise, that spells the word cast. And that's why this is known as the cast rule. The cast rule just tells you which trig ratio is positive in which quadrant. In this quadrant, all trig ratios are positive. In this quadrant, the sine of every angle that brings you to this quadrant is positive. In this, the tan of any angle that brings you here is positive, and the cosine of any angle that brings you into this quadrant is positive. That's the cast rule. Let me show you its use with an example. Consider the cosine of theta is equal to a positive 3 over 5, and the fact that theta is somewhere between 0 and 360 degrees inclusive. Okay, let's find every possible value for theta. If the cosine of theta is 3 over 5, that means that theta is the inverse cosine. It's actually pronounced arc cos, the arc cosine of 3 over 5. And you can verify this with your calculator. That says that theta is 53.1 degrees. I'm going to draw that here. This is about 53. Greater than 45, here's my theta value. And if I were to complete this triangle, I could have a value of 3 here and a value of 5 here. Certainly that ratio. The question is there any other angle that satisfies this equation? Is there any other angle whose cosine is 3 over 5? So the first thing you should ask yourself is, where do I look for that solution? Here everything is positive. Over here, only sine is positive. I'm not going to look here. Cosine is not positive. Over here, only sine is positive. Over here, tan is positive, so I'm not going to look here. And over here, cosine is positive. So my other answer, between 0 and 360 degrees, is going to be down here. My other answer is going to have, this is a side length of 5, and this side length is still 3. And the angle in question is this one. Starts at the positive end of the x-axis and goes counterclockwise. Notice that under here, this angle is the same as this angle because we have the same corresponding side lengths. That makes this angle in here 53.1 degrees. So the other angle I'm looking for, counterclockwise off the positive side of the x-axis, theta 2, I'll call it, is 360 degrees, which is starting here a full rotation minus 53.1 degrees. That makes it 306.9 degrees. You can verify with your calculator. Find the cosine of 53.1, you'll get 3 over 5, or 0.6. Find the cosine of 306.9, you will also get 0.6. You don't always subtract your original angle from 360. It depends on what quadrant you end up in. Let's say we were doing sine instead. If the sine of the angle was 3 over 5, that would bring us into this quadrant to start with, but we'd be looking for our second answer over here. And if our second answer was over here, our reference angle would be here, and we would subtract our reference angle from 180 degrees instead of 360.